Good morning, everyone. I am Daisy Gallardo and I will discussing to you about the coefficient of determination. Learning objectives. First, to learn what the coefficient of determination is. Second, how to compute it. The coefficient of determination is a number between 0 and 1 that measures how well a statistical model predicts an outcome. Interpreting the coefficient of determination. Coefficient of determination, or R squared. 0. Interpretation. The model does not predict the outcome. Between 0 and 1, the model partially predicts the outcome. And 1, the model perfectly predicts the outcome. What is the coefficient of determination? The coefficient of determination, or R squared, measures how well a statistical model predicts an outcome. The outcome is represented by the model's dependent variable. The lowest possible value of R squared is 0, and the highest possible value is 1. Put simply, the better a model is at making predictions, the closer its R squared will be 1. Example. Imagine that you perform a simple linear regression that predicts students' exam scores, or dependent variable, from their time spent studying, and dependent variable. If the R squared is 0, the linear regression model doesn't allow you to predict exam scores any better than simply estimating that everyone has an average exam score. If the R squared is between 0 and 1, the model allows you to partially predict exam scores. The model's estimates are not perfect, but they are better than simply using the average exam score. If the R squared is 1, the model allows you to perfectly predict anyone's exam score. More technically, R squared is a measure of goodness of fit. It is the proportion of variance in the independent variable that is explained by the model. Graphing your linear regression data usually gives you a good clue as to whether its R squared is high or low. For example, the graphs below show two sets of simulated data. The observations are shown as dots. The model's predictions, the line of best fit, are shown as a black line. The distance between the observation and their predicted values, or the residuals, are shown as purple lines. You can see in the first data set that when the R squared is high, the observations are close to the model's predictions. In other words, most points are close to the line of best fit. Note, the coefficient of determination is always positive, even when the correlation is negative. In contrast, you can see in the second data set that when the R squared is low, the observations are far from the model's predictions. In other words, when the R squared is low, many points are far from the line of best fit. Calculating the coefficient of determination. You can choose between two formulas to calculate the coefficient of determination, or R squared, of a simple linear regression. The first formula is specific to simple linear regression, and the second formula can be used to calculate the R squared of many types of statistical models. Formula 1. Using the correlation coefficient. Formula 1 is equal to R squared is equal to quantity R to the power of 2, where R person correlation coefficient. Example, you are studying the relationship between heart rate and age in children. You find that the two variables have a negative person correlation. R is equal to negative 0.28. This value can be used to calculate the coefficient of determination, R squared, using Formula 1. R squared is equal to quantity r to the power of 2 is equal to, or r is negative 0.28 to the power of 2 is equal to 0.08. Formula 2, using the regression outputs. Formula 2, r squared is equal to 1 minus RSS over TSS, where RSS, sum of squared residuals, TSS is equal to total sum of squares. Example, as part of performing a simple linear regression that predicts students' exam scores or dependent variable from their study time independent variable, you calculate that our, our, our sum of squared residuals is 629.22. Our total sum of square is 2187.04. These values can be used to calculate the coefficient of determination r squared using formula 2. Our formula is r squared is equal to 1 minus RSS over TSS. 1 and our RSS is 629.22 over our TSS is 2187.02 is equal to 0.29. So 1 minus 0.29 is equal to 0.71. Interpreting the coefficient of determination. You can interpret the coefficient of determination R as the proportion of variance in the independent variable that is predicted by the statistical model. Other way of thinking of it is that the R is the proportion of variance that is shared between the independent and dependent variables. You can also say that the R is the proportion of variance explained or accounted for by the model. The proportion that remains 1R is the variance that is not predicted by the model. If you prefer, you can write the R as a percentage instead of a proportions. Simple multiply the proportions by 100. R squared as an effect size. Lastly, you can also interpret the R as an effect size, a measure of the strength of the relationship between the dependent and independent variables. Psychologist and statistician Jacob Cohen, 1988, suggested the following rules of thumb for simple linear regressions. R squared as an effect size. Minimum coefficient of determination or R squared value. 0.01 effect size interpretation is small, 0.09 medium, and 0.25 is large. Be careful. The R squared on its own can tell you anything about coefficients. Example, interpreting R squared, a simple linear regression that predicts students' exam scores dependent variable from their study time independent variable has an R of 0.71. From this R value, we know that 71% of the variance in students' exam scores is predicted by their study time. 29% of the variance in students' exam scores is unexplained by the model. The students' study time has a large effect on their exam scores. Studying longer may or may not cause an improvement in the students' scores. Although this causal relationship is very plausible, the R alone can tell us why there's a relationship between students' study time and exam scores. For example, students might find studying less frustrating when they understand the course material well, so they study longer. So that will be all my part. Thank you and God bless.